signal. The upper limit is a few times 10 to the minus 8. Similar. You can see there's a lot of modes. Current reached 10 to the minus 8. So in this for a particular scenario, it starts to eat away a lot of new physics scenarios. If you can get the 10 to the minus 9, everything here will be gone. Okay. So new super factories. Now it's not super B anymore, but BL2 is still surviving. For some mode, especially 3 Lepton mode, we can achieve less than sensitivity close to a few times 10 to the minus 10. Okay. So this is very promising. Directly come from the new physics scenario. Okay, so last slide before conclusion is that I want to show you another way of looking at the lepton flavor violation. Is you can use the Meson decay to a different flavor of leptons. So in Babar, we look for from what's on 2s and 3s to E tau and U tau, reduce the upper limit down to a few times 10 to the minus 6. Okay, so this is just a data and neural net output signal over here. And you can again draw exclusion plots. Use this effective Lagrange. So this is my conclusion slides. So hopefully I show you that the importance of the flavor physics is actually very essential for solving the mystery of particle physics, and it's actually the rich and diverse program. We certainly hope that the charge lepton flavor violation can see something new and very profound, and it is a clean and ambiguous sign of new physics we've observed. It reached up to thousands of TeV, and it has the power to distinguish new physics models with many different kind of measurements. It also is complementary to the high energy experiments. And there's certainly a very exciting future with a very tasty flavor physics. Thank you.
Okay, question. If ILC is still in Japan, what types of, what kind of flavor physics you can come up with that might be interesting?
I'm not sure because certainly they tend certainly recently we were talking about building something like a Higgs factory. So there are a lot of Higgs studies there. I'm not sure how much flavor physics you can do directly at ILC. It's certainly not designed for that.
Other questions?
So what's the, listen carefully. What's the reach of the lepton flavor violation in your case?
In you want?
Yeah, for your future expectation. And compared to the BEL2 on tau decays.
Oh, well, I don't have that comparison directly, but in most models, the muon reach is better. Because if you look at the I think this, if you just take the face value here, we're talking about 10 for EGM, we're talking about 10 to the minus 13 and 14. And tau, you're talking about 10 to the minus 9 or so. Right.
But that's a mass difference between power and
Right, mass difference, you consider mass difference and possibly coupling of the third generation is higher, maybe bigger. So you probably get a factor of hundreds of thousands or so. So it's kind of up there, but no, it's hard to say, depending on your model.
What's your major contribution in topics covered in this talk?
Right, so some study goes into this future, the expectation of the future scenario of the mu to E gamma. So we did some study here. This is first, this is a simulation study. Think about how we're gonna design the next generation of detector. And for the current ongoing experiment, the current more tangible design experiment is the mu to E part. So we're as a group we are responsible for the calorimeter, the design and R&D. So I personally I'm involved in the some simulations and the optimization of the geometry design, etc. Now we are going to have testing on the crystals that's coming up, and we are going to have a test beam later this year for the prototype of the crystal.
How's the funding for the whole project?
The whole project, right? So there will be the CD. So in the U.S., the DOE approval process is called the critical decision, and there are several stages. So it starts with CD0, CD1, CD2, blah blah, until CD4 when you start the operation. Right now, the mu to E has passed CD1, and there's going to be a CD2 and 3A something this year. Okay, but right now it looks pretty good, and the whole budget is, I don't remember the exact number, like around $250 to $270 million, I think, if I remember correctly. And right now, it's kind of high priority in the Tribulet project. So it's looking good.
Okay, I think. Are there any final questions? Because there's a second talk. We should stop now. Okay. So if there are no further questions, let's thank Dr. Cheng again.